Hi everyone, today we'll be talking about how to write in scientific notation. Scientific notation is a way of writing really big numbers and also really small numbers. It's typically noted by a coefficient a times 10 to the power of b, which is the exponent. So for example, if I have my coefficient is 3.2 times 10 to the power of 2. Okay, so 10 to the power of 2 is 10 times 10, which is 100. Therefore, 3 times 2 times 100 would be 320. So it may seem, 320 is a lot easier to write than 3.2 times 10 to the 2. Okay, that's fine, but when you're dealing with really big numbers, this way of writing scientific notation is quite helpful. Okay, so we're going to do some examples where we go from standard notation, so this is the way you've always seen numbers written, to scientific notation. So in our first example, we have the number 3 million meters per second. The 3 million will have a decimal at the end. Every number has a decimal at the end. Even if it's not written, you have to assume that the decimal is at the end. So I'm going to move my decimal after the first non-zero number that I see. So we read from left to right, so the first non-zero number that I see is 3. So I'm going to stop my decimal after the 3 and see how many spaces it took to move that. So we have 1, 2, 3, 4, 5, 6. So my exponent is the number of times that I moved. And since 3 million is a large number, it's a number greater than 1, my exponent will be positive. So we would write this number 3.0 times 10 to the 6th power. Now, in this case, the 3 million, as we saw it before, has only one significant figure. So I'm going to keep that consistency when I write in scientific notation. So the final answer will be 3 times 10 to the 6th. In the next example, we have 0.006030. Now this number is going to be less than 1, so my exponent will be negative. And I'm going to stop the decimal after the first non-zero number that I see as I read the number normally from left to right. So as we're reading this number, we can see the first non-zero number is the 6. So I would stop my decimal right there. Additionally, this number has 4 significant figures. The leading zeros are not significant, but the 6, the 0, the 3, and the 0 at the end are all significant. So I'm going to write this in scientific notation, but the coefficient must have 4 significant figures. So we're going to move our decimal 1, 2, 3. So I moved my decimal 3 places to the right, and that would mean that my exponent is -3. So this is how you would rewrite that. So this number would be 6.030 times 10 to the -3 joules. Okay. For the next one, it's another small number. This number is less than 1, so my exponent will be negative. And we're going to count how many places it takes to go from the decimal from where it is to right between that 1 and the 2, because 1 is the first non-zero number that I see. So we're going to count those places. So I counted 7 places from the decimal and right after the first non-zero number, which is 1. So the scientific notation would be 1.2 times 10 to the -7 meters per second. So before we continue, one thing I want to mention that always helps students is to realize what the negative exponents mean, okay? If you have 10 to the negative 1, that's the same as 0.1. If you have 10 to the negative 2, that is 0.01, so that's 100th. If you have 10 to the negative 3, that's 0.001, so that's 1,000th. So it makes sense that the negative exponents are numbers that are smaller than 1, okay? If you look at it from the other side, if you have 10 to the 1, that's just 10. If you have 10 to the 2, that's 100. And if you have 10 to the 3, that's 1,000. So the positive exponents are going to be large numbers, and the negative exponents are going to be small numbers, okay? Here where we have 10 to the 0 is 1, well, anything to the 0 power will be 1. So keep these in mind as you're going through these. Don't be so confused about, oh, is it a negative exponent or is it a positive exponent? Think about the number logically. Is it a small number? You're going to have a negative exponent. Is it a large number? Is it greater than 1? You're going to have a positive exponent. Okay, so in the last two examples here, we're going from scientific notation and we're going to convert that to standard notation. So when it comes to the numbers with negative exponents, I know it's going to be a really small number, so I just give myself a little bit of room. I'm going to copy down the coefficient. In this case, it's 1.86. And I can see that the exponent is negative 7. So I'm going to move the decimal to the left 7 times. 1, 2, 3, 4, 5, 6, 7. And then I'm going to put my decimal right here. And then I'm going to fill in the little loops here with zeros. And you can see why scientific notation is so nice, because otherwise we wouldn't have to write all these zeros. We could just do times 10 to the minus 7. But the standard notation for 1.86 times 10 to the negative 7 is the same thing as 0.000000186. Okay. For the last one, it's a large number, meaning it's greater than 1. So it has a exponent of 2. 10 to the 2 is the same thing as 100. So with the coefficient, it's 7.346. I always just write down the coefficient, and then I'm going to move the decimal place to the right this time because this number is larger than 1. So I'm going to move it 1, 2. Okay, so this number is the same thing as 734.6. Okay. So hopefully that helped you, and now you can try. Thanks.